Hi, in this video we will dive into the fascinating world of patterns and numbers, uncovering the beauty and simplicity of geometric sequences. A geometric sequence is a sequence of numbers where each term is found by multiplying the previous term by a constant called the common ratio. It's like a chain reaction where each number influences the next. Let's take a look at an example. Here we have the sequence 2, 4, 8, 16, 32. Can you spot the common ratio? Exactly. The common ratio here is 2. That means each term is obtained by multiplying the previous term by 2. And this property is what distinguishes geometric sequences from other types of sequences. Let's go for more practice problems to get you familiar with this topic. Look at this example. They said, determine if the sequence is geometric. If it is, find the common ratio. Here we have -1, 6, -36, 216, and so on. Is this a geometric sequence? Let's find the common ratio. If there's a common ratio in the sequence, then it is a geometric sequence. To find the common ratio, we divide the consecutive terms to see if they give the same ratio. But we start from the next divided by the previous. So what do we do here? We do 6 divided by -1, which is equal to -6. We do also -36 divided by 6, which is equal to -6. And 216 divided by -36, we get -6. So as you can see in this question, the common ratio is -6. So this sequence is a geometric sequence. Let's look at that. Here we have 4, 16, 36, 64, and so on. So as we did in the previous question, we do 16 divided by 4, which is equal to 4. After that, 36 divided by 16 is going to be equal to 9 over 4, which is not equal to 4. And that clarifies that this sequence is not geometric. Let's look at some other types of questions. Here they said, given the explicit formula for a geometric sequence, find the first 5 terms and the 8th term. The sequence is an equals 3 to the power n minus 1. The explicit formula for a geometric sequence could be written in the form an is equal to a1 times r to the power n minus 1. This is called the explicit formula. So here we have an is equal to 3 to the power n minus 1. Now, to find the first 5 terms, we can easily replace n by 1, by 2, by 3, by 4, and by 5 to show you that this is a geometric sequence. Let's replace n by 1. So we can say a1 is equal to 3 to the power 1 minus 1, which is 3 to the power 0, which is 1. What about a2? We say a2, replace n by 2, is going to be equal to 3 to the power 2 minus 1, which is equal to 3 to the power 1, which is equal to 3. What about a3? a3 is going to be equal to 3 to the power 3 minus 1, which is equal to 3 to the power 2, which is equal to 3 to the power 2 is 9, so we can write 9. a4 similarly is 3 to the power 4 minus 1, which is equal to 3 to the power 4 minus 1 is 3. 3 to the power 3 is 3 times 3 times 3, which is 27. And a5 is going to be equal to 3 to the power 5 minus 1, which is equal to 3 to the power 4, which is equal, 3 multiplied by itself 4 times, is going to be equal to 81. And those are the first 5 terms. Now, to find the term number 8, we can do similar process by replacing n by 8. How do we do that? Let me show you how. We say a8 is going to be equal to 3 to the power 8 minus 1, which is equal to 3 to the power 7, which is equal to 2187. You can do this by calculator, by the way. Let's have another example. Here we have an equals to -4 times 3 to the power n minus 1. Let's write it. an is equal to -4 times 3 to the power n minus 1. Now, we can find a1 and r straightforward from the formula. We can say that a1 is equal to -4 straightforward, which is the number here. And we can say that r is equal to 3, which is the number under the power. As we mentioned the explicit formula at the beginning, we said an is equal to a1 times r to the power n minus 1. So now we have a1 is equal to -4 and the ratio is equal to 3, so we can straightforward find a2, a3, a4, and a5. So we can say -4 is the first term, multiply minus 4 by 3, you get minus 12. Multiply minus 12 by 3 is going to be equal to minus 36. And similarly, minus 36 times 3 is going to be equal to minus 108. And then minus 108 times 3 is going to be equal to minus 324. Now we got the first 5 terms. To find the term number 8, we can say A8 is equal minus 4 times 3 to the power. Replace n by 8, you get 8 minus 1. And calculate it, you get minus 8748. And this would be the term number 8. Let's have another type of questions. Here they said, given the recursive formula for a geometric sequence, find the common ratio, the first 5 terms, and the explicit formula. They said here an equals to an minus 1 times 2, and a1 is equal to 2. Since an is equal to an minus 1 times 2, which means that the common ratio is 2, because an is equal to the previous term times the common ratio. So we know that r is equal to 2, and we have a1 is equal to 2 also. So we can find the first 5 terms. So the first term is 2. We multiply it by the common ratio, which is times 2, you get 4. The term after, 4 times 2, which is equal to 8. 8 times 2, which is equal to 16. And 16 times 2, which is equal to 32. So those are the first 5 terms. Now, to find the explicit formula, how do we write the explicit formula? We write an is equal to a1 times r to the power n minus 1. And we replace the values. We say an is equal, how much is a1? a1 is 2, so we write 2 times. How much is r? r is also 2, and we put the power n minus 1, and that would be the explicit formula. Let's have another example. Here we have an is equal to an minus 1 times 5, and a1 is equal to 2. From the first part, we can find that the ratio is equal to 5, and the first term is given here, which is a1 is equal to 2, and we can start from here. We can say 2 multiplied by the common ratio, which is 5, you get 10. 10 multiplied by the common ratio by 5, which is 50. 50 times 5 is equal to 250. 250 times 5 is equal to 1250. And those are the first 5 terms. And to find the explicit formula, we can write an is equal to a1 times r to the power n minus 1. Replace a1 and r and you will be there. So let's say an is equal, a1 is 2, we put 2 times, and the common ratio is 5, and we put the power n minus 1, and here you are. Let's have another example. Given the first term and the common ratio of a geometric sequence, find the first 5 terms and the explicit formula. As you see here, a1 is equal to 0.8 and the common ratio is minus 5. So we can say 0.8, the first term, multiplied by minus 5, you get minus 4. Minus 4 times minus 5, you get 20. 20 times minus 5, you get minus 100. And minus 100 times minus 5, you get 500. And those are the first 5 terms. Now, the explicit formula, we can say an is equal to a1 times r to the power n minus 1. You need to memorize this. Let's replace a1 and r, so we can say it's equal, a1 is 0.8 multiplied by, the common ratio is minus 5 to the power n minus 1, and this is the explicit formula. Let's have another example. Here they said, given the first term and the common ratio of a geometric sequence, find the recursive formula and the 3 terms in the sequence after the last one given. As we see here, a1 is equal to minus 4 and the common ratio is equal to 6. How do we get the next 3 terms? We can say minus 4 is the first term, multiply it by r, which is 6, you get minus 24. And minus 24 multiplied by 6, you get minus 144, multiplied by 6, you get minus 864. This is a product, you can multiply it normally. Now, for the recursive formula should be represented in this form. an is equal to an minus 1 times the common ratio, So we can write it again. an is equal to an minus 1 times, what is the common ratio? Is 6, so multiplied by 6. And always we should add the first term, so we write a1 is equal to minus 4, and this is the recursive formula. Let's have another type of question. Given a term in a geometric sequence and the common ratio, find the first 5 terms, the explicit formula, and the recursive formula. So as you see here, a4 is equal to 25, and the ratio is equal to minus 5. They want us to find a1, a2, a3, a4, and a5. And as you see here, a4 is given, so here it's 25. To get the term after, we multiply by minus 5. So multiply by minus 5, what do you get? Minus 125. Now, since you multiply by minus 5 to get the next term, how do we get the previous term? We divide by minus 5. So 25 divided by minus 5, you get minus 5. Divide by minus 5, you get 1. 1 divided by minus 5, you get minus 0.2. So here are the first 5 terms. Now they're asking you to find the explicit and the recursive formulas. To find the explicit formula, we can say an is equal to a1 times r to the power n minus 1. Replace a1 and r, so you get an is equal minus 0.2 times, the common ratio is minus 5 as it's given up. We write minus 5 to the power n minus 1. And that is done. Let's find the recursive formula. We say an is equal to an minus 1 times the common ratio. What is the common ratio? It's minus 5. We should add the first term, so we say a1 is equal to minus 0.2, and those are together. Another type of questions. Here they said, given 2 terms in a geometric sequence, find the 8th term and the recursive formula. The 2 terms given here are a5 is equal to 768 and a2 is equal to 12. To find a8, we need to find r. How do we find r? Let me show you how. We can write a5 is equal to a2 times r to the power 5 minus 2. Remember when we wrote an equals to a1 times r to the power n minus 1? So here we have 5, here we have 2, so we put it as a power 5 minus 2. Similar to what we did before, like n minus 1. Now we replace a5. a5 is equal to 768 is equal to a2, which is 12, times r to the power 5 minus 2, which is 3, divide by 12, divide by 12. Now 768 divided by 12 is going to be equal to 64, equals 12 and 12 cancel, you get r to the power 3. Now r to the power 3 equals to 64, which means that r is equal to, we say cubic root of 64, which is 4. Now to get a8, we can say a8 is equal, we can use any of the 2 terms given, a2 or a5, so we write a2 times r, which is 4 to the power 8 minus 2, and we replace a2, we can say it's equal, a2, we have a 12, so it's 12 times 4 to the power 8 minus 2, which is 6, and we simplify, we get it's equal to 49,152. We got a8, now we need the recursive formula. To be able to write the recursive formula, we need the common ratio, but we need also a1. How do we get a1? We can say a2 is equal to a1 times r. We have a2 12, and we have the common ratio is 4, so we say a1 times 4, divide by 4 each side. You can get a1 is equal to 3. So we can say a1 is equal to 3. Now the recursive formula would be an is equal to an minus 1 times the common ratio. The common ratio is 4, done. And here we have a1 is equal to 3, and that would be the recursive formula. I hope I covered most of the ideas, and here I can say that we reached the end of the video. If you like the video, don't forget to like and share, and welcome to Math for Fun, and bye for now.